So yesterday, in my Dr. Picklestein Facebook page, I submitted the following. A man in a restaurant asked a waiter for a juice glass, a dinner plate, water, a match, and a lemon wedge. The man poured enough water onto the plate to cover it. If you get the water on the plate into this glass without touching or moving the plate, I will give you $100, the man said. You can use the match and lemon to do this. A few minutes later, the waiter walked away with $100 in his pocket. How did the waiter get the water into the glass? Well, I'm going to demonstrate a way to do this. So in my version of this, I will not be using a lemon, nor will I use a match. Instead, I'll use a candle. And what I'm going to do is use the candle itself, light it, and let it warm up the air in the glass. And as it's warming up in the air in the glass, there will be lots of movement of the air molecules, and you'll see an expansion. And what will happen is that warmed air will begin to flow out of the cup even. Then I will place the cup on top of the candle. I'll put it all the way on the plate, and eventually the candle will go out. When the candle goes out, the air inside the cup will begin to cool. As it cools, it will condense, and the shrinking air inside will create a difference in pressure from that which the atmosphere is pushing down on the water. The differential in pressure will cause the water on the outside of the cup to be pushed down upon by the atmospheric pressure, and it will flow into the cup. So that's what you're going to see here. On occasion, I've heard people talk about this very same experiment, and their explanation for why it works is that the oxygen gas in the cup gets used up as the candle burns, and that creates a vacuum. Well, that's not entirely true, although I can see where they would think that. The reason why that isn't correct is because when something burns, it may use up oxygen gas, but it also gives off other gases as combustion products. And so there really isn't a big change in pressure. So it really has to do more with the warm versus cold air and the movement of molecules. So there you have it. Pretty neat.